let's take a look at some of the common troubleshooting tools or methodologies we'll use with switches. Now right now we've focused mostly on the media without really focusing on some of the actual configurations of our switches. So one of the things we did do, though, was assign an IP address to an VLAN interface, which I said was a logical interface associated with all of the other interfaces by default. Everybody's in VLAN 1, and we'll talk about those. Ping is a command that works at layer 3 to basically try to make a connection determination with a far end device. So if I have two switches and they both have a VLAN 1 interface, as long as they have unique IP addresses and are in the same network, I should be able to ping from one switch's VLAN 1 interface to another. Now, again, I think I said this before. Ping, I've told, stands for Packet Internet Groper. I think of it as the idea of the submarines when you send out that little sonar pulse, waiting for that sound wave to bounce off the enemy's submarine and come back to you so you can tell how far away it is. But it was a way to verify connectivity. That's what we're doing. So there's actually two parts of this message. It uses a protocol, by the way, of communication called ICMP, the Internet Control Message Protocol. The first part is an echo request. And on the other side, it sends an echo reply if it hears the request. The goal is to let you know that you can connect from one point to another point across that physical media. And so when you do a ping, typically what you're going to see come back, if successful, is a series of exclamation points on your Cisco command line. It sends 5 pings by default. And you might actually see sometimes on the first try a period, which means it timed out. That means, I'm only waiting so long to get that reply to come back. Now, technically speaking, if it's the first time you've pinged an address, you might see 2, maybe 3 of the periods. But that's because there's some time that your switch is going through trying to learn the MAC address that belongs to that IP address. Because again, remember, it's not in my table by default. We have to do ARP to go find it. And then after that, if you do a ping, you'll see it's successful all the time. You could also try to ping through the switches. If your switches don't have VLAN interfaces configured, but you have 2 or more PCs connected to either the same switch or several switches, and those switches are connected together, you could do a ping from your Windows machine to a Windows machine or a Linux machine to whatever through the switches with the same, again, goal of trying to verify connectivity from a point to a point. In Windows, it looks a little different. For the way the data comes back, they send 4 by default, and usually actually the words reply, so you know that you made it there. Now, one of the reasons, as I said, for having the use of the VLAN interface with an IP address is so I can make a management connection without having to be directly connected to the console port. You can use a variety of tools. Microsoft, if you install it, has a client where you can be a Telnet client, and you can open up the Telnet client and type in the command Telnet, followed by the IP address of that VLAN interface. And then from there, in this, we've set up usernames and passwords and all that sort of stuff. You should get a prompt that is the same as if you were connected to the console port. Or there's programs that you can download for free. One's called PuTTY that allows you to do Telnet. And all you have to do is supply the IP address and basically click on Connect. Or if you are already in a switch and the command line interface of a switch, you are allowed to Telnet from your switch to another switch. Again, so long as you have an IP address and the other one has an IP address so that they can connect. And since we haven't talked about routers, they need to be in the same subnet as well, or as I said before, the network. And either way, when you do that, you're going to see the prompt that shows you're in user exec, and then you just go on from there, doing all the configuration options that you need to. Now, copper wire can have some problems. Any wire does. With copper, usually the wiring could be a case of the actual copper wire breaking. I mean, it's a very thin copper wire, and if you've got somebody abusing that wire, bending it back and forth, that copper wire is at some point going to become weaker, develop cracks, and could break. And it's really difficult to detect where a break is in a copper wire because it's covered by all of the shielding. Or it could be a new electromagnetic interference source. Somebody puts a new microwave oven next to a cable run that's going maybe under the cabinet. Or as I said, somebody maybe installed fluorescent lights or anything that's going to change. Traffic patterns also change with the addition of new servers and new services. Maybe you've just put voice over IP in. And so traffic patterns could have the appearance of causing a problem, only because now traffic may be going slower because you've overloaded the throughput capability of the wires. And of course, new equipment installation can also be a problem in that, especially when you may have people unplug cables, plug them back in, put them in the wrong spots. It reminds me of a funny story I wish I had time to tell you about a person I met and told me how they learned networking in the early days. But the new equipment is potentially a problem, as cables can get pulled out or, again, could get misplaced. Fiber media is made out of a small glass tube. And I don't know when the last time was you tried to bend the glass very far, but at some point when you bend it too much, it cracks. And that can cause the light to escape outside of that fiber optic core and not be able to get to the end point. I also mentioned that the place where you connect the wire, the actual fiber optic cable, to the connector that's going to fit into the interface card, that you have to be very careful to make sure that you have no light leakage at that location, or again you're going to lose signal. So the splicing can be an issue, or the way in which we actually attach it to the connector and then the connector into the network card itself. So you have to be very careful that you don't bend the cable. You don't leave fiber optic cable from device to device to hang by its own weight, because its own weight could cause, again, stress or cracks. So we're often always tying the cables up to the racks so that they don't have to be fighting gravity at the same time. When we're looking at troubleshooting media issues, one of the first things I would actually ask you to check is it plugged in before you came over here? So if you have no or bad connection, one of the first commands we run is the show interface. And what we're doing is looking to see the interface status. And if it's down, that is an indication that we have a damaged cable or connector. If it's operational, and we do the show interface, then if you remember I said we have a variety of statistics that we can look at. Problems with frames being received, which could be an indication, if I have a lot of dropped frames, that there's some sort of EMI or excessive noise that could be causing the actual frames to become corrupted. And of course, the other one might be the duplex settings, where we could look for dropping from collisions. And again, so we can basically look at the stats to see if it's up, is there too much noise, if it's not that, are there collisions, if those, and if all of those look right, then we should actually have a successful connection. Otherwise, we have to figure out, is it too long of a cable, is there some interference, or is it a settings issue that we can fix? Whenever we're troubleshooting and we do a show interface, one of the first things we're always looking for is what we call the up and up. So one is the actual cable itself. Is it connected? If it is, if it's not, it'd be down. Notice we have the interface status and the line protocol status. So the interface status tells me electrically that it's connected if it's up. If it's down, that means I'm not getting an electrical signal, which means the cable could be unplugged. Or the other side of the link is disconnected, so there's no electrical signal coming in, which is certainly a problem. And of course, that also could be down because of another interface problem that we'll talk about a couple examples here when we do further troubleshooting. But down is the status of the interface, like I said, basically turned on or turned off. Line protocol. So what's a protocol? Well, Ethernet is a protocol. And if there's a problem in the negotiations of Ethernet, connection problem, we might see a down even though the physical cable is up. Obviously, if the physical cable is disconnected, then we always expect to see the line protocol down. Nothing to negotiate, right? But if it's up and the protocol is down, then that could be an indication of a problem. It could even be potentially a noise problem, but it's generally configuration options. The last one is administratively down. That means that you purposely issued the shutdown command and that you wanted this port to actually be turned off. Then, of course, we'd expect the protocol to be down at that point as well. So excessive noise can cause a lot of the problems with CRC errors. Now I know that's not fair to use a different acronym than what we've been calling it, which was FCS. Remember, at the end of every frame there's a checksum. We call the frame check sequence FCS, but it can also be called the cyclical redundancy check. I think I know why it's called FCS. That's easier to say. So what do? Look for damage in the cable, make sure you have the correct length, or search for sources of noise. If you're getting excessive collisions, well, that's normal if you're doing half duplex, because both sides might choose to talk at the same time. Only one can talk and receive. You can't do both at the same time. Or if you can, fix it by going to full duplex, even better. If you have excessive late collisions, that could be a duplex mismatch. That just simply means if I have one side doing full, it thinks it can talk and receive at the same time, right? So the half duplex guy starts talking. The full duplex guy receives that transmission and then says, oh, hey, I can talk at the same time, sends their connection out or their communications out, and then we've got more collisions again. Again, configure both sides to have the same duplex settings. All right, so in doing your show command, again, part of what you're going to see is what we call the counters, right? Usually the last 5-minute counters or total counters. It just depends on what we're looking at. So we're looking at a part of one here that talks about how many packets were in, how many bytes that it was, the different number of broadcasts, a lot of different information. But what we're looking for here are things like input errors. The input errors is where you fail what we call the sanity check, right? Looking at that checksum to make sure that that it was correct. Another one you might see is we had a high number of output errors causing a whole bunch of collisions. Again, that could be a problem in dealing with the half to full duplex mismatch. Again, here 135 late collisions again. So that's how we begin to determine where we might want to start looking for troubleshooting, is looking at these stats that are coming from the output of our show interface command. So like I said, many of the common port issues are related to duplex and speed, assuming the cable is not broken and that both sides are plugged in. So again, the duplex ones results from a mismatch, and you can get a mismatch, believe it or not, if you have one side set to auto and one side set to full. Sometimes the auto just doesn't do the negotiation, or there's a problem in that communication. So you could just manually set both sides to full. Right now, though, setting both sides to auto, it's been years since I've had a problem with those negotiations, but it could be a problem. The same when setting up speed. If you set up one with a specific speed and the other side to auto, that could also cause some mismatches in speed. All right, so there are lots of examples of duplex-related issues. One end, again, set to full duplex, the other to half duplex. That's a mismatch and will result in a lot of collisions. Or if one end is set to full duplex and the other is set to auto, if auto negotiation fails, and it might revert actually back to half duplex, which again would be a mismatch. If one end is set to a half and the other is set to automatic, if the auto negotiation fails and that end reverts to half duplex, then both ends are going to be in half duplex, and of course there's no mismatch, but you also have lost a whole lot of throughput or speed. Other types of duplex-related issues, the auto negotiation set on both ends. If one end fails to full duplex and the other one fails to half duplex, again, you could have a problem. Like I've said, I've seen this happen before, where sometimes you just have to physically turn them both to full so you don't have to have to worry about an auto negotiation failing. Speed-related issues are going to have the same problems when it comes to some of the auto negotiations. If one end is set to one speed and the other is set to another speed, then there's going to be a mismatch. You're going to have error messages all over your screen. If one is set to a higher speed and auto negotiation is enabled on the other end, then basically if the auto negotiation fails, the switch is going to sense what the other end is using and hopefully will revert to an optimal speed. But if auto set on both sides and auto negotiation fails, then they will revert to their lowest speed. And at the lowest speed, there's a problem there because now you're having a lot less of the bandwidth capability. So you might perceive a problem even though there's no mismatch. Troubleshooting your duplex again, if you have no or a bad connection and you're getting this little sign right up here popping open all the time on your screen, that's where we have to do a show interface. on both sides, by the way, to check for a speed mismatch. If there is, fix the speeds on one or both of the sides. If there's not a speed mismatch, then we can look for the duplex. If we're getting that, then again, manually on one or both sides, fix the duplex problem. That should be very easy configurations. One command changes to be able to get rid of those errors and be able to actually get transmissions to go back and forth without problems. By the way, it is the Cisco Discovery Protocol, which we haven't talked about, that does that discovery of the settings on the interfaces. Again, one more time to see how easy it is to view the settings. With the Show Interface command, just come down about 5 or 6 lines and look to see the settings. Full auto, 100 megabits, or basically I should say full or half, 100 megabits or 10 megabits. Remember, we can't go faster because that's a fast Ethernet. All right, so we took a look at some troubleshooting commands and tools like ping to test end-to-end connectivity, telnet to be able to administratively connect to a switch, to be able to do administration's command line work. We talked about some of the switch media issues that are common, mostly duplex and speed. We talked about sources of interference potentially or damage to cables. And we talked about how to fix the mismatches between speed and duplex by either the configuration commands or how to verify the settings with the Show interface.